In this video, we will learn how to find the derivatives of trigonometric functions without using chain rule. Okay, so I have a lot of examples there for you. Let's start with the first one. Okay, so here we have 2 sine x minus 5 cosine x. We need to find the derivative of that. By the way, on the upper right side of your screen, you can see the equivalent derivatives of the following. So for the derivative of sine x, that's just cosine x. So that means for this one, this is 2. Derivative of sine x is cosine x. I'll write cosine x here. Minus 5. Cosine x, derivative of that is negative sine x. Okay. Now we need to simplify this part. Our final answer is 2 cosine x plus, because negative sine x and negative 5 is positive, 5 sine x. And that will be our final answer. Okay, let's answer the second one. Here we have cosine x over 2 sine x. So obviously we will apply the product rule here, or sorry, quotient rule here, because we have an f function and a g function. I'll write first the formula for the quotient rule. That's f prime g minus f g prime all over 2 minus sine x, sorry, g square. Alright, derivative of our f cosine, that's negative sine x. And then our g is just 2 minus sine x. Okay. Minus cosine x. And then the derivative of 2 minus sine x is negative cosine x. Okay. Divided by 2 minus sine x square. Okay, so let's distribute the negative sine x to 2 and negative sine x. So this will be equal to negative 2 sine x plus sine square x. So this is negative cosine x and another negative cosine x. So that will be equal to positive cosine square x divided by 2 minus sine x square. Now we have a situation here. We will apply some of the identities, trigonometric identities. We are familiar with that, right? That equals 1. So that means this is equal to negative 2 sine x plus 1 all over 2 minus sine x squared. And that's our final answer for this example. All right, let's go to the next one. All right, so let's answer this third example. Okay, derivative of negative 4x to the negative 3 power is positive 12 x raised to negative 4. Negative 3 minus 1 is negative 4. And then minus. Okay, so for this one, we will apply the product rule. Okay, that's x squared, which is our f, cotangent x, which is our g. So derivative of f is 2x, and then g is cotangent x, plus x squared. Then derivative of cotangent is negative cosecant square x. Okay. So if you want, you can actually make the exponent there positive. That's fine. If you don't want, I believe that's okay, but again, it depends on your teacher. So this is 2x cotangent x plus, or sorry, minus x squared cosecant square x. Now let's get rid of the bracket. This is going to be equal to 12 over x raised to 4 minus 2x cotangent x plus, you distribute that negative sign, so x squared cosecant square x, and that's going to be our final answer. Let's go to the next one, and I believe this is the second to the last, if I'm not mistaken. Yep, that's the second to the last example. Okay, so there's a lot of product rules that we will do here. Well, actually not a lot, but for this part only. Okay, so let's agree that this is our f and this is our g. Okay, so f prime is just 3 cosine x, okay, times cosine x plus 3 sine x times the derivative of cosine x, which is negative sine x. Okay, so what I did here is just this. Okay, so plus derivative of cosecant is 2 times negative cosecant x cotangent x. Right? Okay, so this is now equal to 3 cosine square x plus, okay, or minus rather, 3 sine square x minus 2 cosecant x cotangent x. Okay, we can simplify this further, and as you can see here on this right side of your screen, there's an identity that we can use. Common factor is 3, so 3 cosine square x minus sine square x minus 2 cosecant x cotangent x. Now this is equivalent to cosine 2x, so that's a double angle identity. So our final answer is 3 cosine 2x minus 2 cosecant x cotangent x. There you go. All right, let's go to the last example. So I have 5x secant x plus x tangent x. So there are two product rules that we will do here. So for this one, right, we have the f and the g, and then for this one, f is x, g is tangent x. All right, for the first term, which is 5x secant x, derivative of 5x is 5, then secant x, plus 5x derivative of secant x is, okay, secant x tangent x. All right, so that's just for 5x secant x. For the second one, that's 1 tangent x plus x times the derivative of tangent x, which is secant square x. Okay, so derivative of 5x is 5, and then copy secant x, and then 5x, which is f, derivative of secant x is secant x tangent x, plus 1 derivative of, or yeah, derivative of x is 1, and then tangent x plus fx, and then derivative of tangent x, which is secant square x. Okay, so let's simplify this one. This is 5 secant x plus 5x secant x tangent x plus tangent x plus x secant x secant square x. And I believe we can't combine anything here, so this is going to be our final answer.